Infrastructure is the cornerstone of modern society. From the supply of energy and water and the treatment of waste to the provision of effective healthcare and education systems, it is infrastructure that transforms society, enabling it to function effectively, grow, and prosper. Fundamental challenges surround planning for and provision of infrastructure systems in the 21st century. Socioeconomic development, population growth, and climate change are rapidly changing the world we live in. These changes will significantly affect long-term demand for and provision of infrastructure, but there are vast uncertainties around how it will affect infrastructure. There is also a growing frequency of short-term shocks and disruptions to infrastructure, from natural and man-made hazards such as flooding and conflicts. This affects the performance and reliability of these essential systems. That's why it is essential that infrastructure today is robust and has long-term functionality, in order to continue operating in spite of changing future conditions. Infrastructure should be resilient so that it can respond, adapt to, and quickly recover from shocks and disruptions. Therefore, we need to plan to provide long-term infrastructure systems that meet current demands and needs without compromising the ability of future generations to meet their own demands and needs. Currently, short-term sector or silo-based planning of infrastructure is widespread, particularly in the developing world. This approach fails to provide robust, resilient, and sustainable solutions to the 21st century challenges we face. For infrastructure to be truly sustainable, we need to take a look at the bigger picture, the entire lifespan of infrastructure, the demands placed upon these essential systems, and the interdependencies between them. We therefore need a paradigm shift in the way we think about and plan for infrastructure.
As the central resource for infrastructure development within the United Nations system, the United Nations Office for Project Services recognizes and understands this need for a fundamental change in thinking. And so we're pioneering support to governments in this transformation towards a systems-based approach for infrastructure planning and development to help them tackle the challenges of the 21st century. We're committed to support governments develop robust and resilient infrastructure through strategic evidence-based investments in infrastructure systems that will underpin strong economies to drive good standards of living, not only for today, but also to afford that same right for future generations.
What is infrastructure? Infrastructure generally refers to the fundamental facilities and systems serving a city, region, or a country, which are necessary for the economy and society to function. Traditionally, this definition has been used to describe physical structures such as roads, water supply, electrical grids, and telecommunications, as well as hospitals and schools. UNOPS is collaborating with the Infrastructure Transition Research Consortium, ITRC, to support long-term infrastructure-based solutions for developing countries in improving and developing infrastructure, using the latest best practices for the decision-making, planning, and implementation of infrastructure.
The ITRC has built the world's first system of systems modelling capability, which goes right the way across energy, transport, water, waste, digital communications. And we're using that to inform long-term decision-making about national infrastructure.
The National Infrastructure Plan is a pioneering achievement that the UK government has put together. It's basically all the major projects and programs for infrastructure, which underpins the economy, helps provide the needs of communities, helps drive economic growth. So they've got all the major projects and programs together in one plan, and underpinning that is the pipeline, which is about £460 billion worth of investment in infrastructure. With the NISMOD LP tool, we're able to put in the national infrastructure pipeline projects and project into the future alternative worlds of different demographics, different climate change scenarios, and see how well the pipeline does.
Based on our collaborative work with the Government of Norway and the Infrastructure Transition Research Consortium ITRC, led by Oxford University, we understand infrastructure as more than just physical assets. Infrastructure also includes the knowledge and institutions involved in the planning and governance of such assets and systems, as well as the services and transformational functions it provides. We also recognize that modern infrastructure cannot be thought about in isolation as just standalone assets or entities. Infrastructure exists as a highly interdependent system of systems across cities, countries, and regions.
What are the interdependencies? Let's first consider the energy sector. An entire system of infrastructure operates within this sector. It includes standalone assets such as power generation plants, as well as the links between this and the other parts of the infrastructure. This includes physical links such as transmission network to distribute the power, and the non-physical links to the knowledge and institution needed to build and operate the energy systems, the governance and financial systems, and the training facilities that provide qualified staff. Let's take a step out. The power generation plants are reliant upon other infrastructure systems, such as a functional water system to cool the generation plants. Similarly, the water system is dependent upon energy so that its pumps can be operated. Both infrastructure systems rely on institutions to develop, regulate, and maintain them, and these institutions are equally dependent upon water and energy systems needed for their offices to function. Such interdependencies exist across all infrastructure systems.
The electrical blackout, which swept across Italy on the 28th of September 2003, demonstrates how the breakdown of a single infrastructure asset can generate cascading failures throughout infrastructure systems due to the interdependencies between them. Damage to a power line following storm caused a short circuit, which triggered an outage of power across the country. This resulted in the breakdown of the rail network, healthcare and financial services, and severely affected the communications network. The partial failure of the communications network in turn further impaired the power grid management system, stalling its recovery. This is an example of a system with low resilience. A better understanding of system interdependencies is needed to highlight vulnerable assets in the system, so that investments can be made to safeguard them, reduce risks from disruptions, and plan for swift repair and recovery. This is even more critical to countries that are prone to disaster. Failure to consider infrastructure interdependencies is particularly problematic in the developing world, where it can prevent projects from achieving the intended development impact and the expected value for money, as well as risking the robustness of infrastructure.
A recent development programme, with the objective to improve citizens' access to justice, built a number of new courthouses in a lower middle-income country at a capital cost of $64 million. In the affected country, as in many countries, government ministries are generally only responsible for the infrastructure assets that are considered part of the individual ministry portfolio. Therefore, when planning the courthouses, the responsible ministry overlooked how their operation would affect demand for other infrastructure assets and services. This silo-based approach led to unmanaged risks to the investment decision. These additional courthouses require access to water, energy, additional staffing, and additional operations and maintenance to be functional. Paying for these requirements in order to operate the courthouses increased the annual operations cost to the government by approximately $4.4 million. This is a significant additional financial burden for a developing country, and consideration of such factors was not evident in the planning process. As a result, the function of the completed courthouses is at risk, and the intended development impact of improving citizens' access to justice has been jeopardised. This government has since recognised the need for a more strategic approach to infrastructure, but many other countries still need to achieve this change in approach to infrastructure.
The world cannot rely on short-term planning and implementation to provide sustainable solutions to the challenges posed by a growing and developing population, which is placing unprecedented demands on the planet's limited resources.
Long-term national infrastructure planning anchored to a development vision is needed, along with an understanding of the interdependencies of assets, knowledge and institutions across and between all systems of infrastructure. This will allow governments to make the most efficient use of existing assets and to prioritise new projects so as to effectively use scarce financial resources to maximise socio-economic benefit and to protect the environment. Working with our partners, our goal is to help governments develop this capacity in long-term evidence-based planning, design and operations of infrastructure systems, based on the adoption of best practice structures, systems, models and tools that are adapted to suit the local context. In doing so, we strive to support the development of infrastructure that is both resilient to the short-term shocks as well as robust to the long-term uncertainties, so that it enables sustainable human development now and for the future.